Hello, welcome again. We are solving some questions of theory of machine. The topic is displacement, velocity, and acceleration of planar mechanism. Question number 16 is match list 1 inversion applications with list 2 fixing link of single slider crank and reciprocating compressor IC engine. uh, List 1 reciprocating compressor IC engine, 2 Whitworth quick rotating mechanism, rotating cylinder mechanism, 3 oscillating cylinder mechanism, oblique slaughter lever quick rotating mechanism, 4 hand pump. List 2 A cylinder, B connecting rod, C piston, D crank. So codes, option A1, A1, B3, C4, D2. Option B A3, B4, C1, D2. Option C A1, B2, C3, D4. Option D A1, B3, C4, D2. So here in a reciprocating cylinder or reciprocating compressor IC engine, cylinder is a fixed link. So A is corresponding to 1, and in connecting rod is fixed in oscillating cylinder engine or floater lever mechanism. So B is corresponding to 3, and piston is fixed in hand pump. So C is corresponding to 4, and crank is fixed in Whitworth mechanism. In Whitworth mechanism, shortest link is fixed. So D is your 2. So answer is option A. Okay. Next, so answer is option A. Okay. Next, question number 17 and 19. So this is the figure, and here in the figure OA is your 250 mm. Okay, and OP dash is OP dash and OP double dash is 100 mm. AR dash, AR double dash is 450 mm. So above figure shows a slotted lever mechanism with extreme positions and dimensions. The line of stroke passes through the extreme position of the pre end of the lever. Okay, of the pre end of the lever. So question number 17 is inclination of slotted lever with the vertical in extreme position. So this is your slotted lever, and we have to find out the inclination of it with vertical. Inclination of slotted lever with vertical in extreme position. Option A 23.6, option B 66.4, option C 48.1, option D 39.1. Question number 18 is the ratio of time of cutting stroke to the time of return stroke. Option A 1.71, option B 2, option C 2.5, option D 1.90. So answer time of cutting stroke to return stroke. Okay, and question number 19 is length of stroke 291.1 mm, B 360.3 mm, C 314.1 mm, D 307.1 mm. So here this is your link AR dash, and its length is given as AR dash or AR, and AR have same length. So length is 450 mm, and OA is given as 250 mm, and now we have to determine this angle alpha by 2, and OP dash is given as 100 mm. So at the extreme position this angle will be 90 degree. Okay, so cos beta by 2 will be OP dash. OP dash is base, and this is your hypotenuse because this angle is 90 degree. So OP dash is given, OA is given, so we can find out beta by 2, so that is 66.4. Okay, and beta will be 132.8. Now we have to find out this angle, so we can subtract this beta by 2 beta by 2 from 90 to get alpha by 2. That angle is angle of slotted lever with vertical. is 90 minus 66.4, that is 23.2. So the question rating is we have to find out the ratio of cutting stroke to return stroke, time for cutting stroke to return stroke. So this is your this is the angle traveled during cutting stroke. Okay, and this is the angle traveled during return stroke. If this crank rotates at constant angular velocity, so then as the crank rotates in constant angular velocity in crank floater lever mechanism, because this is the input link, then uh, the time of cutting stroke and time of return stroke is directly proportional to ratio of time of cutting stroke to return stroke is directly proportional to angle transferred by crank. So during cutting stroke the angle traveled is 360 minus beta, and during return stroke the angle traveled is beta, because because return stroke has to be faster. So that will be 360 minus beta by beta, and beta is 132.8. So the ratio of cutting stroke to return stroke is 1.71. Next is length of stroke, and length of stroke is SS dash, or we can say it is R dash, R double dash. Okay, so and AR is given as 450 mm, and this angle is your alpha by 2. So now this is again a vertical 90-degree angle. So this angle is alpha by 2, and this length is also given, that is AR or AR dash. So as this is hypotenuse and this is your alpha by 2, so this will be your sine AR dash, as R double dash is 2 AR dash sine alpha by 2. So it will be 2 into 450 into sine 23 by 6, because alpha by 2 is 23 by 6. So length of stroke will be your 360.3 mm. So answer is option B.